In this video, we're looking at bipolar graphs. So before we can even construct bipolar graphs, we need to understand that bipolar graphs are actually based on the results of an environmental perception survey. So you notice when you do such surveys, you get two aspects here, the positive aspect as well as the negative aspects. And that is why we create a bipolar graph after that, because a bipolar graph tells you two different opinions about something. So let's say we ran a survey on 10 people, and these are the results collated by the 10 people. So for example, when a person looks at a particular tourist attraction, they realize that 6 of them thinks that it should be a -1. The buildings in that particular area not quite well maintained. So 6 of them thought it was -1. 3 of them thought that actually the buildings are quite well maintained. So +1. And then 1 of them thought that it should be a +2, pretty well maintained. And let's look at human traffic. 2 of them think it's a -2, so very high human traffic. 3 of them think it's -1, so relatively high human traffic, but maybe a bit bearable. 1 of them had no effect, chose to be neutral. 4 of them thought that there's pretty low human traffic. About unpleasant surroundings, 1 of them thought it should be -2, 4 thought it should be -1, 2 were neutral, 2 chose +1, and 1 chose +2. So you notice that all the pluses are associated with the positive aspects of that particular site, and the minuses are associated with the negative aspects of that particular site. So basically people, when they choose a plus or a minus, they're leaning towards a more negative aspect, or they're leaning towards a more positive aspect. You would also notice that in an environmental perception survey, the two extremes are about the same thing. So if you're talking about maintenance of buildings, the negative side will be not well maintained, the positive side would be well maintained. You're comparing the same thing. Next one is about human traffic, so high versus low. Next one is about surroundings, how pleasant or unpleasant it is. So what we have to do from this data set is to plot it in terms of a bipolar graph. So notice the title of the graph here, Environmental Perception Survey of a Location. So the location can be anywhere given in that particular fieldwork question you receive. And you notice also 0 is here, and the numbers are different from the numbers that you see previously. So these are maximum 2, but here you get 8 or even more than that. What you also notice are the categories here: buildings, maintenance of buildings, human traffic, surroundings. All these categories match the categories given in the environmental perception survey. So basically you have to do a bit of calculation before you map the survey results onto the bipolar graph. So here's how we do it. We're not going to care anything about the zeros, because that's not going to affect our results. Those are people who thought that it was neutral. We're going to care about the negatives as well as the positives. So let's look at one data set or one characteristic at a time. Talk about maintenance of buildings first. 6 people thought that it's -1. So 6 times -1, that gets you -6. So I go to my graph here. I look at -6. I'm going to plot it here. This is -6. Go back to my survey. I look at the pluses. 3 times 1 gives me 3. 2 times 1 gives me 2. So if I add it together, I would get 5. So I go back to my graph here. 5 is around here. I connect my graph. So -6 here and 5 here. Of course, use a ruler to draw this to make your graph look a bit neater. Or during an exam condition, they might already give you the graph lines, the grid there. Moving on, let's look at high human traffic. So again, I'm going to look at all the negative numbers. -2 times 2 gives me -4. 3 times -1 gives me -3. So -4 minus 3 gives me -7. So again, I'm going to plot it on the graph here. High human traffic is -7. It's somewhere here. So I'm going to draw the line to the middle here. Going back to my survey, 4 times +1 gives me a +4. So I go back to my graph. 4 extends all the way here. Back to the survey, negative here. 1 times -2 is -2. 4 times -1 is -4. So -2 minus 4 gets me -6. Go back to my graph. Where is -6? -6 is about here. I connect it. Go back to the survey. 2 times 1 is 2. 1 times 2 is also 2. So I add it together, I should get 4. Go to the graph. I find 4. And I can plot it here. So again, make sure your lines connect properly. So basically what I've done is I've looked at the survey results here. I processed the survey results. And then using that analysis, I plotted my bipolar graph. So what is the use case of a bipolar graph? So in this case, what we did is we constructed the graph. But what if the graph is already given to you and you're asked to make interpretations of it? Okay, by right, you're supposed to color the graph in, but it's fine if you don't. So let's say you colored it in. This graph actually helps you to understand whether people think of that location positively overall or negatively overall. So you will notice for this graph here, most of the time, it leans towards the negative side. So what you can say is that typically people think of that tourist location as something negative. And you want to support your answer with the fact that, for example, building is not well maintained. You have a -6. High human traffic, -7. Unpleasant surroundings, -5. But on the flip side, those who think that it's positive, the degree of positivity is not that high as well. The highest number you see is 5, but the rest are 4 and 4. So a bipolar graph gives you a visual representation on whether that place is negative or positive.